All right, good evening. My name is Dale Jones, and I'm going to be speaking this evening on optimization and code profiling. Not that I'm trying to pass myself off as any expert. In fact, I would say most of this I never really needed to know until the last few years. So that may be your situation, and it may not. I don't know. Okay, maybe I'm going to present that. All right, we'll do it this way. From what I've been able to pick up from different sources on the topic, the general consensus seems to be if you don't need to go squeeze an extra speed out of your code, don't do it. Typically, it's better to have it readable, maintainable, easy to understand. People have done some really awful, horrible things to their code trying to get extra speed out of it and not necessarily doing it. So, a few choice quotes on the topic. First rule of program optimization, don't do it. The second rule of program optimization, for experts only, don't do it yet. And we'll see why. Most of us have probably heard this much of this quote before. Donald Knuth says we should forget about small efficiencies about 97% of the time. Premature optimization is the root of all evil. Yet we should not pass up our opportunities in that critical 3%. You can read the rest of it. But at the end he says, it would be wise to look carefully at the critical code, but only after that code has been identified. Rob Pike tells us bottlenecks occur in surprising places, so don't try to second guess and put in a speed hack until you have proven that's where the bottleneck is. Which takes us to profiling. The code profiler, if you're not familiar with it, gather statistics on your code execution as it's running. There are a couple of different kinds. There are subroutine profilers that give you information at the subroutine level. There are line profilers that will go line by line and give you statistics on how many times a line was executed, how many times, or how much time was spent executing it, hopefully. The old way of profiling was to use a module called devel dprof. That's been a standard module since Perl 5.6, so most people have it. But don't get too hung up on it, because later I'm going to tell you don't use it. But if it's all you have,
better than nothing.
We'll hope it's better than nothing. Using it is really simple. Invoke Perl with the -d:\dprof option then the name of your code and whatever options you would need to pass to it. That will create a statistics file as it runs. When you're done, you run this other program, dprofpp. It'll analyze the output and show you a little summary of, good grief, of the things that are taking up the most time in your code. So here's an example I did running Perl tidy on itself. And it shows a little summary section, tells us how long it spent executing the program, how much actual wall clock time elapsed, and then it gives a list of the 15 procedures using the most time. Okay, so that's handy. But some of the decisions that made sense back in 1995 don't necessarily still make sense. And word is that as CPUs have become faster, the results you get from dprof may be sort of random.
Is that through multi-core? Basically,
no, that's
cores at it and stuff like that?
That's a separate issue.
Oh, okay.
Just as CPUs have gotten
clock speeds.
Yeah. According to some of the things I read, it'll measure things every 100th of a second, which doesn't sound right, but that's kind of what I remember reading. So kind of wherever your code happens to hit on those ticks is what gets measured.
Interesting. Totally throws your timing off. That's good. All right, cool.
So now the preferred way is to use a newer profiler, NYTprof. It was started by a guy named Adam Kaplan, who was working at the New York Times at the time. And then after he released it, Tim Bunce of DBI fame jumped on it and added more improvements to it. There are so many things about NYTprof that are better than the old one. I took a partial list from the Perl doc. Not only does it do per subroutine profiling, it also does blocks like loops and if statements. It also does line level profiling. It'll even do opcode profiling and tell you things like how much time was spent on regular expression matching, calling print, different things like that. Captures your source code. It says it handles applications that fork. I've never tried it. Also says it's trivial to use with mod Perl if that's your thing. But the best thing about it is the HTML reports that you get later on. So it's two profilers, a statement profiler and a subroutine profiler. And this would be a good time to look at some results. So if we do basically the same thing that we did with dprof, although I didn't stop and show it. We want to run the profiler against Perl tidy on Perl tidy. say that we want to send the output to a different file so it doesn't try to overwrite the regular old Perl tidy. Now, once you've profiled the code, I should stop and mention you can analyze the runtime statistics and get output in several different formats. One of them is a CSV file. I'm not sure why you'd want it, but it's available.
Database.
If you're used to being maybe a kernel hacker, I understand there's a tool they use quite a bit called kcachegrind. Not familiar with it, but you can get output in a format suitable to use with that tool. The one that most people will use is HTML. So we'll let it generate the HTML reports. It gives you a little status as it goes. Because for big chunks of code that it profiled, that can take a while, and it's nice to know how it's coming along.
It's pretty slick.
All right, so here we get the same sort of summary data. We spent 2.5 seconds out of 4.12 seconds of wall clock time executing that many statements, doing that many subroutine calls in that many source files, and we did 8 string evals. You run this against your own code, it'll be much more interesting and meaningful to you. Here's the same list of the top 15 subroutines that we got from dprof. And here we've got different columns for the number of times a procedure was called, how many places it was called from, if you want to know where all your code is being used.
I'm assuming the time is actually accurate.
It's supposed to be. Gives you the inclusive time spent in the procedure. The exclusive time and the inclusive time, which would be not only the time in that procedure, but also the time spent calling other procedures from that procedure. Okay. Most of the columns here are sortable. So if, for example, I wanted to know what was being called the most often, why am I not getting my sort options?
Is there a message on your Firefox? It's like orange down in the lower right. Is that normal?
Yeah, that's normal. Okay, anyway, typically those things would be sortable. And over here, everything is cross-referenced. So if we wanted to go and look at maybe not get up long find option, because if I was worried about Perl tidy, I'd probably worry about something in Perl tidy. So let's say I went off and looked at this one. It's telling me that it's giving me the line view. But the block view and the subroutine level views are also available. Oh, come on. Okay, naturally it has never ran like this at home. Anyway, once you get down here, it'll tell you for the subroutine it spent 438 milliseconds within Perl tidy tokenizer get line, blah, 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 blah. The interesting things to note are that you can go and click on other places where this procedure was being called. So you can walk up and down your call stack, which can be really handy. And then it summarizes at the different levels, how many times a line was executed, how much time was spent on that line. What were my other two columns? I've forgotten.
Looks like there's sort of, at least one of them.
Okay, statements, time online, calls, and time in subs. Okay. Oh yeah, a couple of things I didn't mention. It'll produce call graphs for you, which may or may not be very useful. They tend to get really cluttered very quickly, but they are available. Again, more of the same kinds of summary information and call stack information. There's just lots of stuff to look at, and I don't want to spend a lot of time on it. When you run it against your own code, that's when it becomes interesting.
Right.
And I keep trying to do the dual monitor thing and go from the television to my laptop. Okay. It's not a standard module like dprof was, so if you want to use it, you'll probably have to go off and install it yourself. As we saw, you invoke pretty much the same way. There are lots of things you can control through the nytprof environment variable that can control different aspects of data collection. If you don't want line level collection, you don't have to get it. Turning that off speeds things up. If you don't want to start collecting data I don't know, until the very end, maybe to look at object destructors, you can do that. If you want to say, don't turn on profiling at all, I'll add some lines in my code saying when to start and when to stop because I'm targeting a specific section, you can do that. Lots of things you can do. I would refer one to the Perl doc. Here's your different formats. Looks like I jumped the gun a little. There's another module out there. It's not really a profiler. It's called Benchmark. Is everybody familiar with it? Okay, should I skip over that one?
Sure.
All right, I am going to stop for a minute and take a look at this little example. I made two square functions that return the square of a number. And then just to see the kinds of things we can get, after we run the comp these function, which is only one of the things that's in there, prints out a little list of what it did, how many times per second it was able to do each one of them, and then there's a little grid where it compares each function to the other function, so you can see how much slower or faster one of them was compared to another. So interestingly, I did one of them using the exponentiation operator. The other one I just did multiplication. And it said the one doing plain old multiplication was faster. But if you look at my functions, you might think, hey, wait a minute. That's not quite an apples to apples comparison there, is it? Okay, so that's profiling at a real high level. Once you've identified some things that you want to speed up, there are some simple things you can do. There's also a lot of other stuff you can do. I'm not even going to try to talk about everything. Typically, the biggest improvements you'll see will come from changing your algorithms. That also might be the most work you could do. So depending on how big of a speed improvement you need, you may want to do that, you may not. One of the things you can do, and some of these are going to seem pretty obvious, move invariant functionality out of loops. And I've seen some really bizarre things being done over and over again inside of loops. Things like constant declarations, you don't need to keep doing those. If you're working with the database and you can prepare a statement one time, that can make a huge difference. And again, I've seen things. Another thing you can do with smaller functions in particular, leave the parameters alone instead of doing the repeated shifts. If you just do them all at once, that'll be faster. If you've got short functions where you're not going to get confused and readability isn't an issue, then don't even mess with the parameters. How many times will I do that tonight? Okay, it's a little smaller now, but if we go back to our example from the benchmark section, here I've added two new functions, square 1a and square 1b. Both of them are using exponentiation. Neither of them is doing anything with the function parameters. They're just accessing them directly. And then the second one here doesn't even have the return. Apparently, the people who study this stuff more than I have say every piece of Perl code is going to cost you something. So down here, we can see the A and the B functions. The one without the return is now the fastest one. Is it less readable? Kinda. So based on your circumstances, figure out which one is more important to you. If you can skip subroutine initializations, until you know that you don't need to exit a subroutine early, then by all means see if you can leave the subroutine early. I know log for Perl will do that. It'll check as soon as it can to see if you're logging at something below the level where it needs to display something, and exit as soon as it can. Caching can be a good strategy. It's not always, but it can be. One example of where it would not be would be if it takes something to look up longer, takes longer to look something up in the cache than it does to recompute the values. Something like the square functions, I haven't benchmarked it, probably would be slowed down if I tried to cache the results. If all your function does is look up something in a hash, don't try to cache that. Okay, one specialized example of caching is the Schwartzian transform, named after Randall Schwartz, of course. If you're doing something, if you're sorting a list and the comparison operation is fairly expensive, this can be useful. If you're not familiar with it, it's easier to start at the end and read backwards. But you start off with your original list of things, you map it into an array of 2-item anonymous anonymous arrays, where the first element is the original item from the list, and the second element is your computed value. Then you do your sort based on the computed values, and then you call map again to pull back just the original items. I've used that for things like sorting a list of input files by size. Instead of going off and hitting the file system to get the sizes of 2 files every time I do a comparison, I only have to do it once. And for other things, one time where we used this, we had some functions that would go off and retrieve a value out of a database. There were all kinds of values we could have gone out and picked up from the database. We didn't want to try to go get them all and store them all. So by having our function that would do that and using this memowise module, saying memowise this lookup function, it does all the work. It keeps track of the arguments you pass to it. It keeps track of what comes out. And if you pass it the same set of arguments, instead of going off and doing the expensive whatever it does, it says, oh, I've already done this. Here's your results. Regular expressions. Again, some of these may seem obvious, but I keep seeing things. If you only want to match something at the beginning of a string, anchor that so the regular expression engine doesn't have to keep trying to match something when that's not what you want. If you have parenthesized alternatives and you only want to know if you have a match, but you don't really care which match you found, use that little construct there with the question mark and the colon to say, don't capture what's in the parentheses. Simple regular expressions may be faster than one great big long one. And I would say if you want to know if this applies in your situation, benchmark it.
It's good to know because I hate big long ones because they're hard to debug. So I always break them up, and so it's so easy to debug if something goes wrong.
There you go.
But I didn't know that I was actually gaining a little speed, maybe.
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 Maybe. And if your regular expression is based on some variable where maybe you don't know what you're going to get before you go into a loop, but you know it's not going to change inside the loop, either tack on the O qualifiers so that it'll only evaluate the thing once instead of doing it each time through the loop, saying, oh, this regular expression has variables in it. Typically, it would think it needed to reevaluate and recompile the regular expression. You can tack that on, or you can precompile the regular expression using the QR operator. And I believe that brings us to the end of simple things you can do. And that's all I have.
Excellent.
I'd be curious, yeah, thank you very much. I was just going to say I'm a little curious as to what people have found that helps speed up their code in real life, and I'll start off by giving a couple examples that I found. That I had a few cases where things were just bogging down and taking forever, and I found that hashes tended to be very quick for me in most of my applications, unless it reached a certain size. And over a certain size boundary, I suspect it was maybe caching it to the hard drive, perhaps.
One thing you might be able to do with that, I mean, you should probably profile it as well. But if you actually know ahead of time approximately how large it can be, you can pre-allocate how much memory you want the hash to use. And then that way, because what will happen is, as it's filling up, it's keep allocating more memory, more memory, more memory.
Yes.
If you know it's going to be large to start with, it's quicker to just, as long as you don't mind the memory, that you're consuming more memory for a longer length of time, just to pre-compute how much memory
and I've
you want.
used that, and I would concur that can make quite a speed improvement. I also found that sometimes I was just being sloppy. I had lots of stuff in there I really didn't need to keep in there all the time, so sometimes cleaning out an array at some point makes sense, or a hash. Arrays, if I remember right, were also very slow when you get large, but I think that might have been a different reason. I'm not sure. Has anybody had any experience with arrays? Large, very large arrays?
Very large?
Probably you're running into the...
Yeah, I found it was better to convert to hashes or some other construct than using large arrays. And then the other thing I found, a lot of the scripts I was working with were database intensive, and actually we found out that using a Oracle, we had an Oracle database, an Oracle analyzer helped dramatically speed these things up. It was not a Perl issue, it was a SQL issue, and sometimes it was not even obvious. I mean, you put it through their analyzer and they would make a recommendation, you go, why would that speed anything up? And yet you put it in there and damn if it didn't speed it up. So we got dramatic. I mean, some things that were taking all night long to run would run in like 5 minutes after you put it through an Oracle analyzer.
Yeah, that's a good point. Sometimes the speed improvements aren't what you think.
Well, yeah, actually that raises an interesting thing that I ran into, because we just started using NYT Prof. We just learned about it here. I actually used it on some of my code at home just to mess around with it. And it's funny, you go back to the quotes and it's so true. Your slowdowns are not where you think they are. Because what I was worried about was this was basically a templating system where it was doing a lot of parsing. So I was worried about the parser being slow because that's what it does the most of. That wasn't even on the map. It wasn't even close. That was so blazingly fast, just not even close. What turned out to be the biggest waste was that I had some objects that would stringify to a value if you just tried to use it as a string. Well, what I was doing was I was storing these objects, and then they would get stringified over and over and over and over and over and over again, rather than when I'm storing it, stringifying it then, just putting it in quotes the first time, so then it only gets stringified once, and that's, again, just blew me away. Didn't even think about it that, oh yeah, this is an object, and I'm copying it, and then every single time I access that variable, it has to restringify it. So, anyways, and that was huge, made a huge improvement, and it wasn't even anything that I was thinking about at all. So, but NYT Prof pointed it right out to me what the problem was. At first I looked at it and I go, what? And then, I kind of went through it. And like, oh, yeah, that's what the problem is. When I assign, it should just stringify once. Then it's just a string, and every time you access it, you're just paying the penalty of whatever it is to access the string. So.
That's why the other quote makes sense too. It's usually the algorithm that's the biggest problem.
Yeah, we've probably all heard stories like the one from the company that had a set of nightly batch jobs that would generate a bunch of reports, and as the company started getting bigger and bigger, there was this one that just started getting really, really slow. When they went in to poke around and see if they could figure out why, the original developer had left a comment saying, I understand there are better ways to do this, but I'm implementing bubble sort here because it's the only one I know. It was nice of the person to leave the comment.
Yeah. No, there's a better way to do this.
Yeah, I often leave comments. In 2000 and such years, it will stop working. I'm not worried about it because I'll be dead and gone.
Yeah.
How much of an improvement did you notice when you started pre-allocating?
Well, it's been a little while. It's probably been a few years, but I do recall that at one time I realized that was an option, and once I did that, it was significant. I mean, you can save significant amounts of. This was some serious reams and reams of data crunching type stuff that would run for hours and hours. So for me, it was a very significant savings.
Okay.
Presentation.
Thank you. Hopefully, it'll give you some idea.
Most of the things that take too long are things like the internet, which there's not only so much you can do. Although I have thought about, I'm using LWP. I wonder if there's faster things to use. Like, what was it, LiveCurl, or there was another tool that
Mechanized.
Mechanized.
But they're all, that's all
Mechanized
basically the same.
Yeah.
Basically,
Network
so
sucks.
Yeah.
You
I
move off
figure
the
it's probably
CPU
not
onto the network.
There's probably not much I can do, but.
Although if you're lucky, you can back it against the database, so you only have to hit some data a little bit. But if it's always something new that you're trying to
Well,
get,
yeah, the one I've got in my
fine.
mind right now is a real-time ticker thing that's going out to NASDAQ, so I can't.
Yeah, no, that's.
As soon as a few seconds later is old data. So.
Yeah, there's no help there.
But there is a lot. It's a web scraping thing, so unfortunately you have to do a lot of regex stuff as well. Maybe they'll give us an interface one of these days.
That'd be nice.
Some of them do have APIs.
I think.
I'll have to do some. I don't know about the real-time ones, but yeah. Some of the
Most
delayed
of them are
ones
delayed.
do.
Yeah, Yahoo's are delayed by like I think 15 minutes or 20 minutes.
Yeah, I think those are the only ones you can really get APIs.
Yeah.
I think the other ones you have to pay for.
Yeah.
Yeah, if you pay for it,
Then you'll get an
surprisingly
API.
free with information.
Yes. Yeah.
Not part of the presentation, but kind of funny. That came from the list of Perl infrequently asked questions.
That's good.
Really?
The whole time.
That's not a joke up there?
It's
Use
a-
more-
Yes.
Oh, I
Yeah.
was gonna say.
Worse.
Use all resources.
Geek humor.
Begin, exit. That's a good one. I like that one.
It's quick.
It's quick.
It's quick.
You can do that one fast.
I want 300 CPUs. Everything the server's got.